Okay. Page 2. Awesomeness to ensue. Oh, that's a rhyme. Totally made that up. So, check it out. Things that you want to be cautious of. I'm going to highlight and delete my highlighting. I'm going to highlight in yellow just so you can see where I'm talking. First thing, Abe, is in this piecewise graph, do you see the pink, red, and green are drawn in their appropriate regions? Do you guys remember that the inequalities that you see over here are all about where do I graph that function? So I only graph y equals x when x is less than or equal to 2. I only graph x squared between negative 2 and 1. And I only graph y equals 4 when x is greater than or equal to 1. Now if you remember that, if I'm looking at like the y equals x graph, do you see the closed dot at the end? The equal sign in the inequality? Those aren't an accident. It's filled when it's an equal sign. It's open when it's not an equal sign. I'll show you those. So if I look at like the x squared graph, look at that. X squared is between negative 2 and 1. So I have it between negative 2 and 1. And I have open circles at the ends. The cool thing about x squared, I notice that some of you don't know how to graph x squared, just happenstance. Let me go back and show you. X squared is always, you start at the origin and you go over 1, up 1, over 2, up 4, over 3, up 9, and then you go symmetrically to the left, you do the same thing. Over 1, up 1, over 2, up 4, over 3, up 9. That's how you always build a standard quadratic, like x squared. So I don't care where it's placed. You're thinking over 1, up 1, over 2, up 2. The only thing that would change that is a vertical stretch, which would make those ups that many times bigger. Is there anything on that I can show you? That's just a piecewise function is, so this gateway stuff, the reason Abe says, well, why do I have to know this? These are made specifically because in AP Calc 1, if you go onto that course, the things from this class that are most important, I assembled into gateways so that you know that if you forget anything, don't forget this. So we're going to put it toward the end so that it's most fresh. So if you go into AP Calc 1 and you can transform these basic graphs and do this, there are questions, legitimate questions that come up on the AP exam that are just graphs of these, and they ask you for either areas underneath them, and you have to be able to do it without a calculator and just know what it looks like, or what the rate of change is, or the slope at a given point, or just basic stuff about these graphs specifically. So that's why we do them. And then down below, basic transformations on this. The thing that you do with transformations on a kind of graph that's jagged edge like this, just move the points. I picked 4 points in pink there, and all I do is I do my transformations to those 4 points. And I actually do the coordinates of them sometimes, but right now I'm just going to. So when it says negative f of x and I do a vertical flip, I just take those points. Instead of up 5, I went down 5 to get a particular point, like this one down here. That was down 5 instead of going up 5 in the original. I'll make this a little bit bigger. The other one, same thing. If it's up 4, I go down 4 at the same location. If it was up 1, I went down 1. If it was on the origin, or I'm sorry, on the x-axis, it doesn't change when you rotate it over the x-axis. Cool. And then horizontal flip, same thing. If you guys, I took the graph and I flipped it. This is 2 parts. I flipped it first. That's what you see here in pink. And I'm highlighting. I flipped it first. I took all, if it was to the left one, I took it to the right one. Everything's just literally flipped over the y-axis. I took the points and I traded places. So they used to be on the other side of the y-axis, the same number of spaces. I just transferred them over. And then I went up 2. The second part of the graph is me moving every single point up 2. So I took each point and went up 2 spaces. So this one here, sorry, I was off space, up 2. This point I went up 2 spaces. This point I went up 2 spaces. I'm only messing with those 4 points, not moving anything else. Then, this one's same thing. Is there anything else on this? I did it in parts again. You work from the, I did left 1 first. So you can see my graph went left 1, then I did a vertical stretch of 2. So this is twice as tall. So look what, if you want to see the twice as tall, look at my pink dots that are left 1. Look at their up value got doubled. So this first point's up 5. The vertical point right here is 5. So now it goes to 10. the blue part, and that was at height of 4, I moved it to 8. So I just doubled that. This was at a height of 1, so I moved it up to 2. The last step is to move it down 1. And so I took all of that down 1 space. Took all 4 of those points and moved them down 1 spot. Okay, so that's anything about those you want to ask about real fast, because that's all it is. It's just I did it in parts. I only moved those 4 points. Just do it systematically, kind of carefully. Cool? Anything? You guys are good? Okay, we're almost done with the second page. There is a horizontal stretch. 1/2 x means you actually take it times 2. Anything you multiply to x, it has a reciprocal effect, so it's times 2 over 1. So the original's in pink. And then the red one is I took all those points and horizontally, whatever they were before, this was 4 to the left, I moved it to 8 to the left. The pink is 1 to the left, I moved it to 2 to the left. That's doubling it horizontally. 1 right gets to 2 right because I doubled it horizontally. The point that was 5 right is now 10 right because I doubled it horizontally. So that's the horizontal stretch. You double the horizontal value, double the x value. And next. Inverse function is the reflection over y equals x. So you rotate it about y equals x. And the quick way to do it, if you take the original 4 points, I got the coordinates here in green, you swap them. So -4, 5 becomes 5, -4. -1, 4 becomes 4, -1. You swap their places. The inverse is the swap of x and y for every point. And you just do those 4 points, you swap their coordinates and plot them. And what you get is this cool looking bat thing. Doesn't that look like an insect? So swap x and y, that's the inverse. That's the other thing I noticed. There's a couple of, like, listening wise, some of you guys listen and remember things. You're like auditory. It's kind of crazy. Like, if your head's buried in your sweatshirt and actually listening and remembering, it's kind of freaky. Okay, that's page 2.